Welcome to Monochemistry, and today we're going to learn some basics about how to measure heat transfer. And the equation that we use when we measure heat transfer is the following: Q equals mc delta T. You may have used it before. Hopefully we're going to get in a little bit better understanding of why this is in chemistry, why you might need it for chemistry. Well, Q, just to refresh our memory, is the amount of heat, and it's equal to the mass of a particular substance times its specific heat capacity, which is different depending on the substance, multiplied by the temperature change of that particular substance. Now, this equation is not used to calculate heat transfers in chemical reactions. It's used to calculate heat transfers in physical processes. Okay, so if I take a piece of ice and I heat it up, I would use this particular equation to figure out how much I heated it up. Okay? Or if I have a piece of metal and it's in a rocket ship, I need to know how much the piece of metal is going to heat up if I change the temperature by so much. Okay, so why would chemists use this? Why is it an important thing? Well, since chemistry is basically the study of matter and how it interacts with all of the things in our daily lives, it makes sense that we would study how heat transfers affect particular metals. For instance, we want a pot to be made out of a particular metal because metal allows temperature transfers or heat transfers at a very high rate. So the more we know about these particular things, the more we can use them to our advantage. Okay, so that is just kind of basically why we need to know this stuff. Again, this is not how you calculate heat transfers in chemical reactions, but since chemistry is a study of matter, we look at all of these factors as we go through. The units for this particular thing, for Q, the units for Q are joules. Okay, and joules are the SI unit, the System International unit for energy. Okay, so any type of energy you talk about in this class is going to be measured in joules or kilojoules. And remember, 1,000 joules equals 1 kilojoule. Okay? All right. Yeah, so basically what we're going to look at is we're going to look at a question. It's found on page 633 of the chemistry textbook, not AP chemistry, but chemistry textbook. You can just follow along. So we have a particular glass of water, and the glass of water is being exposed to some ice. Okay? And in the question, we have a mass of 60.0 grams of water. We have the C value for water, which is a constant for liquid water anyway, is 4.184, and that would be joules per gram degrees Celsius. And the change in temperature is, because we're exposing it to ice, equals negative 16.8 degrees Celsius. Okay, so that's the problem. What we're going to do with that now is we're going to actually substitute. So Q equals mc delta T. Q is equal to 60.0 times 4.184 times negative 16.8. Okay, remember our final units are going to be joules, and when you multiply all of those together, you do end up with a negative 4,220 joules. Now, here's the interesting part. We know that we exposed a glass of water to ice. Obviously, the temperature of the water is going to go down. Makes sense. So why then do we end up with a negative value here? Is it possible for a substance to gain negative energy? Not exactly, but it is possible for a substance to lose energy. So if a substance is being cooled, then it's losing energy to its surroundings. Okay, so this would actually be an exothermic process if you think of it from the perspective of the surroundings. Okay, because negative means that energy is being given off. So that's an exothermic process because energy is being given off and the substance is cooling down. If I was to have a positive Q value, then that would mean an endothermic process. Okay, we call this the sign convention. Negative Q values mean exothermic, positive Q values equal endothermic. And that in a nutshell is how you solve these problems. Now, before I leave though, there's just one other thing. It's very important. There's going to be different types of questions. Sometimes you're going to be solving for Q, sometimes mass, sometimes C, sometimes delta T, sometimes TF or TI, which are actually within delta T. Sometimes you're going to be solving for any one of those. So you really have to read the question carefully, put the numbers in where they're supposed to go, and substitute as need be. Use your algebra skills to solve these questions. And again, that in a nutshell is how you figure this stuff out. Please bring your questions to class.